G'day chemists. In this video we're going to look at how to calculate the enthalpy of a system using Hess's law. This particular video we are just looking at the equations method. If you wish to know about the cycles method, we have a video that's just that. We also have a video which is both the cycles and the equations. You should be able to do both, right? Like that's ideal. However, you should also be able to do any question they give you using either method. It's just that for some the equations are going to be the easier path, for some the cycles are going to be the easier path, and ironically it doesn't matter which way you get there, the answer should be the same either way. So in this video we're not going to be such a ninja that we can do it without thinking. We just want to get to the point where we're ready to go practice some of these equations of our own. So we should be able to, by the end of this, to calculate using Hess's law, use just the equation method. All right, let's go. And how we would do this as equations. Okay, so boom, target equation, gold. We're looking for delta H equals X kilojoules per mole. We want to rearrange these equations down the bottom here to match the target enthalpy up here. So I'll show you what that looks like. It's kind of fun. So we write down our target equation. Done. I'm going to label all these A, B, C with a different color. Now have a look. So here we have our 2-methylpropene-1-ol, which is a reactant, but here it's a product. So if we're trying to get it to match this thing, you'll see what I mean in a minute, we need to change the sign of this. We need to flip it. And if we flip that, we have to flip this. That's important. That is a very easy place to get caught out. So we're now going to write A down here, right? See how we flipped it, which means we flipped that. Keep that straight. All right. Good. We've got that written down. Now go for B. Okay, that's this one here. Here we're going for the 2-methylpropene. It's on the right side, so we don't need to do anything to it. And we write that down there. Super duper good. Nice and straightforward. Then we've got our C right here. H2O steam. It's on the right side. Don't need to do anything. So we're just going to put that there. Minus 242 kilojoules per mole. So now comes an important step. It's not important for the calculations of it. It's important for checking that we're doing the right thing. We need to start cancelling out our steps, extra components, to make sure we've got just what we need. All right. This 4C over here cancels out that 4C. These hydrogens plus these hydrogens gives us 5. That cancels out that hydrogen. This half an oxygen cancels out that half an oxygen. So far, so good. And what we see that we have left is we have just the 2-methylpropene-1-ol, the 2-methylpropene, and the steam. Good. That's all we need. Okay, we've got everything we need. Bang, it all works out. Our working's going to be good. So, because delta HX equals the sum of ABCD, or ABC, right, all the way across, we just have to add them together. 335 plus minus 17 plus minus 242 gives us 76 kilojoules per mole. That's it. A nice and straightforward one. Let's see what we've got next. Let's have a look at this one using just the equations. We won't do the cycles here. So, when in danger, the bombardier beetle can fire a hot toxic mixture of chemicals at their attacker. Excellent. Seems familiar. The mixture contains quinone, C6H4O2, compound formed by the reaction of hydroquinone, C6H4 2 hydroxides, with hydrogen peroxide. Nice. The overall equation is this. So we've got the hydroquinone plus hydrogen peroxide gives us quinone plus water liquid. Alrighty. Now, this is our target equation. Okay. We need to watch out for the coefficients. There's a double there. So anywhere where we have this 2, or this H2, and this H2O, so anywhere we have these components, we have to double it, because that's what that means. So these values are going to double as we go. All right, we write down our target equation. Smashing it. Then we're going to write down our other equations and make sure they're all facing the right direction. Okay, so this is facing the right direction. That's on the right side. We'll label them A, B, C, D. So equation A, perfect. We write down the plus 177.4 kilojoules per mole. No dramas there. We have a slight problem. Our peroxide is on the wrong side. It should be a reactant. So we're going to have to flip that. Okay, so we've got the flip, the little signs there. So it becomes hydrogen peroxide goes to H2 plus O2, which gives us plus 191.2. So we've flipped the sign here as well. Then we have reaction C. We have water gas. Now it's not gas there, but it's on the right direction at least. So we don't have to flip this. But we do need to multiply it by 2 to get from our water gas. It's not the same. What do we do about that? So 2 H2s plus O2 gives us 2 H2 steams. We write that down. But that's not where we need to end up. So there's actually another step we need to put in there to go from steam to a liquid. Sweet, easy peasy. Remember, we've got to double it. It's in the right direction because we're going from steam to liquid. Write it down. Put it in there. Now all we have to do is sum up all these values, because delta Hx equals the sum of all of the other delta H's, and we put them in together. 177.4 plus 191.2 plus 2 times minus 241.8 plus 2 times minus 43. That's a minus. The maths still works out, I promise. Gives you minus 202.6 kilojoules per mole. Make sure when you write this out, you put a little minus there, because that comes from there too. It's fallen off. Yeah, so that's how we do it. Same process, a little bit more complex because we had to do some doubling there. We had to do some flipping and some doubling. And let's have a look at one more example. All right. What makes this one trickier is that it doesn't give us all of the equations. Okay, so we're going to have to write some of those down. Let's look into it. Let's see how we go. First off, silane, a silicon hydride, is formed in the reaction of silicon plus hydrogen. Makes sense. Si solid plus 2 hydrogen gases gives us silane as a gas. Fun reaction, because you've got a solid turning into a gas when we add another gas to it. That's pretty cool. It's also not a reaction you can do in a school lab. So the enthalpy change for this reaction is called the enthalpy of formation of silane. So you can see that, right? Like silicon in its natural state at room temperature, etc., is a solid. A hydrogen gas, boom, off we go. We're ready to roll. That's formation. That's using just the elements. However, it's a slightly rarer equation, rarer reaction. So we can't just look up the value for this. So we've got to do some other stuff. So the combustion of silane gives silicon dioxide and water. So here we have silane plus oxygen gives us silicon dioxide plus water. These are two we can work with. And they give us an equation for that. So the enthalpy of combustion of silicon is minus 911 kilojoules per mole, but you don't see an equation there, do you? But you probably know what the products of that reaction is going to be, right? The combustion of silicon is going to give you silicon dioxide. So use this information and the enthalpy of combustion for hydrogen in the data booklet to calculate the enthalpy of formation of silane. Here's where the water molecule is, so you can see where the combustion of hydrogen is going to come in, because hydrogen plus oxygen gives you water. And I've just pulled this out of the IB data booklet. The enthalpy of combustion for hydrogen, H2 as a gas, is minus 286 kilojoules per mole. So, a lot of question there. A lot of different things. We have to write some equations down. We have to come up with them ourselves. So, here's our target equation. The first thing we need to do, enthalpy of combustion of silicon is that minus 911. There's the equation. All right, that's the direction it needs to be. Well, we'll see if that's the right direction in a minute. The enthalpy of combustion of hydrogen, this is the equation right here. And we'll note there's a 2 there, so we're going to have to double it. See, so we double that. because it was half, so that goes up to just regular oxygen, 2 hydrogens, 2 waters, and we'll start to see that matches up. And if you'll notice, that is starting to match up with the 2 hydrogens up there, so that's fun. And the value there is 2 times minus 286. It's fun. It's really fun. Okay, so let's put this all together. We're doing the equations method here, remember. So, target equation, written down. This is the direction and the side that we need things to be on. Okay, silicon's going to be on this side, selene's going to be on this side. So, our first one, which is this one, it has to be flipped because see, our silane is on the left-hand side, the reactant side, and we need that on the product side. So, we write the equation like this. Boom! And we write plus 1,517. We had to flip the sign there. Important. Nailing it. All right. Equation B. That's this blue one. Silicon dioxide. So, silicon dioxide, silicon plus oxygen gives us silicon dioxide. Now, this here seems to be tricky because the silicon dioxide is on the left-hand side, and we know that's right. But the silicon is on the reactant side of our target reaction. So this is the way it goes. So what that means is this step is actually an intermediate phase in the overall reaction if we were doing the cycles method. So we keep that at minus 911. Then we need to bring our water in, okay? So our water needs to be on the needs to be doubled because of this to get us to there, because again that's a middle step, so we want to get to there in the middle, which will then use that to get to there, and so on and so on. So we're at 2 times minus 286 kilojoules per mole, and then we're just going to add them together. That's all it is. So the sum, so enthalpy of X equals the enthalpy of these guys summed all up. We just put them in our equation. Simple arithmetic. 1,517 plus minus 911 plus 2 times minus 286 gives us 34 kilojoules per mole. And we're done. That's it. That's the whole box and dice. I hope that made a lot of sense. If you have any questions, any feedback, whatever, put them in the comments below and we'll get back to you as soon as we can. Thank you for watching. Hope to see you next time. Bye now.